Determining the appropriate wire size for an 8.5 kilowatt 3-wire electrical range involves several considerations to ensure safety and compliance with electrical codes. The primary factor is the ampacity of the wire, which is its current carrying capacity. This must be sufficient to handle the range's electrical demand without overheating. The National Electrical Code, or NEC, provides tables and guidelines for determining ampacity based on wire type, insulation temperature rating, and installation conditions. To calculate the required ampacity, we start with the power rating of the range, which is 8.5 kilowatts. Convert this to watts by multiplying by 1000, giving us 8,500 watts. For a 240 volt circuit, which is typical for ranges, we use Ohm's law to find the current. Ohm's law states that power equals voltage times current, or P equals V times I. Rearranging the formula to solve for current, we get I equals P divided by V. Therefore, the current is 8,500 watts divided by 240 volts, which equals approximately 35.42 amps. However, NEC section 220.55 permits demand factors for ranges. For a single household range rated at not less than 8.75 kilowatt, a demand factor of 8 kilowatt is used. Dividing 8,000 watts by 240 volts gives 33.33 amps. Next, we need to consider the wire type and its temperature rating. Common wire types include THHN, THHW, and XHHW. Each has a specific temperature rating, such as 75 degrees Celsius or 90 degrees Celsius. The higher the temperature rating, the more current the wire can safely carry. Consult NEC Table 310.16 for the ampacity of different wire sizes and types at various temperature ratings. This table lists the allowable ampacities for conductors rated 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. After determining the required ampacity, select a wire size from NEC Table 310.16 that meets or exceeds this value for the chosen wire type and temperature rating. For example, if using THHN wire with a 75 degrees Celsius rating, a number 8 American wire gauge, or AUG, copper wire has an ampacity of 40 amps, which would be sufficient for a 33.33 amps load after applying demand factors according to NEC 220.55. Keep in mind that the terminal temperature ratings must be considered. Many breakers and range terminals are only rated for 75 degrees Celsius, so even if the wire is rated for 90 degrees Celsius, the 75 degrees Celsius ampacity column must be used. Another important consideration is voltage drop. Excessive voltage drop can cause appliances to operate inefficiently and can even damage them. NEC section 210.19, informational note number 4, recommends limiting voltage drop to no more than 3% for branch circuits. To calculate voltage drop, you need to know the wire length, the current, and the wire size. Use a voltage drop calculator or consult NEC Chapter 9, Table 8 to determine the voltage drop for the chosen wire size. If the voltage drop exceeds 3%, you may need to increase the wire size to reduce the resistance and lower the voltage drop. Type of wiring method also affects the allowable ampacity. If the wires are bundled together in a conduit or cable, the ampacity must be derated according to NEC section 310.15. This derating factor reduces the ampacity to account for the increased heat generated by multiple conductors in close proximity. For example, if there are 4 to 6 current-carrying conductors in a raceway or cable, the ampacity must be derated to 80% of the value listed in NEC Table 310.16. Grounding is another critical aspect of wiring an electrical range. The grounding conductor provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. The size of the grounding conductor must be determined according to NEC Table 250.122, which is based on the size of the ungrounded conductors. For example, if the ungrounded conductors are number 6 AWG copper, the grounding conductor must be at least number 10 AWG copper. Finally, be sure to follow all applicable local and national electrical codes and regulations when wiring an electrical range. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to do the job. To summarize, firstly, calculate the range's current draw using its power rating and the voltage of the circuit. Secondly, select a wire type and determine its ampacity rating from NEC table 310.16, considering the temperature rating of the wire and the terminations. Thirdly, choose a wire size that meets or exceeds the calculated current draw, taking into account any dirting factors for bundled conductors. Fourthly, calculate the voltage drop and increase the wire size if necessary to stay within the recommended limits. Fifthly, select the appropriate size grounding conductor from NEC table 250.122. And sixthly, always follow all applicable electrical codes and regulations. Based on a typical installation of an 8.5 kilowatt 3-wire range on a 240 volt circuit, a number 6 AWG copper wire with a 75 degrees Celsius insulation rating is often adequate, but local codes and specific installation conditions must always be considered.